Solving quadratic equations by completing the square. Recall that the standard form of a quadratic is ax squared plus bx plus c equals 0. A perfect square trinomial is a special type of quadratic in the form of a squared times x squared plus or minus 2 times a times b times x plus b squared is equal to 0. That when factored, you have ax plus b times the quantity ax plus b, which you can then rewrite as the quantity ax plus b raised to the second power. This trait can be very useful in solving quadratics because if we can convert any standard form equation into a perfect square trinomial, solving would only require taking the square root of both sides versus potentially needing to use the quadratic formula. So what makes a perfect square trinomial anyway? Well, let's take a look at some, and can you see a pattern between b, c, and the factored form? Here's our first example, x squared plus 10x plus 25. It is equivalent to the quantity x plus 5 raised to the second power, because the factors of 25 that add up to positive 10 are x plus 5 and x plus 5. In this one we have x squared plus 8x plus 16. What are factors of 16 that add up to positive 8? Well, it's 4 and 4, so x plus 4 times x plus 4, meaning x plus 4 raised to the second power. And this last one, x squared plus 6x plus 9, that is equal to x plus 3 quantity raised to the second power. It appears that the term in factored form, so our plus 3, for example, that when doubled is equal to b, that's plus 6, positive 3 times 2 is positive 6, and then if you square this term, you end up getting c. So that's the relationship between each number in the quantity being squared and the b and c terms. This pattern will consistently be true because of how we multiply binomial factors. We would get x squared plus bx plus another bx plus b squared, which then simplifies to x squared plus 2bx plus b squared. We can also rewrite this formally in a different way, but it does have the same meaning. We could end up taking the 2b and write it as 1b, but then we would have b over 2 being squared at the bottom, or at the end. So then we would have the final square form would be x plus b over 2, and that entire binomial being raised to the second power. And this relationship can be used to convert a quadratic from standard form to vertex form, and this process is called completing the square. Let's see how completing the square works. Recall that the term c is found by taking half of b and then squaring it. If we are given the expression x squared plus bx plus c, we can then complete the square. And that extra c term is b over 2 squared. And we're getting that because we're taking half of b, squaring it, and the coefficient that's out in front of this set of parentheses is a 1. And 1 times anything is that value. And then whatever we add to one side, we also have to take away, or add it to the other side if you do have an equation. Since this is just an expression, we're then going to subtract out what we're adding. So then that way, these two terms, the plus b over 2 squared and the minus b over 2 squared, add up to 0. So it actually doesn't change the value of our expression. And now if we distribute the square through to all of our terms here, we would have b squared over 4. And again, distribute the square through, we would get b squared over 4. Now let's do some exercises where we are completing the square, and we're going to check our answers. So we have x squared plus 10x plus some number. Well, that's going to be our b value of 10. It's going to be 10 over 2, and then we're squaring it. So 10 over 2 is 5, and 5 squared is 25. And then the factors of 25 that add up to positive 10 are positive 5 and positive 5. So written as a perfect square, or the binomial squared, would be x plus 5, that entire quantity raised to the second power. Now let's look at the next problem. We have x squared plus 16x plus some number at the end. So we have to take our 16 divided by 2 and then square it. Well, 16 divided by 2 is 8, and 8 squared is 64. And then what goes in this blank space of the binomial is the 16 over 2, which is 8. And again, we can check our answer, because if we do have x plus 8 times x plus 8, we would end up getting x squared plus 8x plus another 8x. There's our 16x plus 64, so it does work. Now let's look at this next problem. We have t squared minus 2t plus some number. So now our b term is negative 2. So we're going to take negative 2, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. 1 squared is positive 1. And then, what are the factors of positive 1 that add up to negative 2? It's negative 1 and negative 1. So you have t minus 1, that quantity raised to the second power. Now let's look at our last problem that we have here. X squared minus 18x plus some number. So we're going to take our negative 18, we're going to divide it by 2, and we're going to square it. Negative 18 divided by 2 is negative 9. Negative 9 squared is positive 81. And now what are factors of positive 81 that add up to negative 18? That's x minus 9 times x minus 9, or x minus 9, that entire quantity raised to the second power. And here are the answers to these exercises, and they do match the solutions that we found. And remember, the way to check the answers is to take the binomial that's being raised to the second power and multiply it by itself. And if it does end up equaling the trinomial that is shown, then we are indeed correct. Now let's continue by discussing how to complete the square on one side of an equation where we have a constant on the other side of the equation. So when we have x squared plus bx is equal to c, we would then take half of b and square it to get b squared over 4, and we would add that to both sides of the equation. Before, we were adding that b squared over 4 and then subtracting it when it was in the same expression. When we have an equation, instead of adding something and then subtracting it out, we can just add the same value to both sides of the equation to keep it equivalent. And then when we factor this left side, it becomes x plus or minus b over 2, and that binomial raised to the second power, and that will be equal to what's on the right side, c plus b squared over 4 that we added to both sides. So let's try some exercises to see how this works. We have x squared plus 8x plus some number is going to be equal to 9 plus that same number. We're going to add it to both sides. So we're going to take 8, our b value, divide it by 2, and square it. So 8 divided by 2 is 4, and 4 squared is 16. And whatever we add to one side, we have to add to the other. And we could factor this if we needed to. It would be x plus 4 quantity squared. Now let's look at the next one. We have x squared minus 18x. We're going to take negative 18, that coefficient in front of the x, divide it by 2, and then square it. So that's negative 9, quantity squared is 81. So we're going to add 81 to both sides. And if we were to factor this, it would be x minus 9, quantity squared, and it would work. Now let's look at the third one. We have h squared plus 14h plus some number is equal to negative 18 plus some number. So we're going to take our coefficient b, 14, we're going to split it in half, and then we're going to square it. Half of 14 is 7, and 7 squared is 49. So we're going to add 49 to both sides of the equation. And if we were to factor this, it would end up factoring to be h plus 7 quantity squared. And here are the solutions to these exercises, and they do match the solutions that we found. And now that we have found the blank number to add to both sides of this equation, this was the first one in the last set of examples where we added 16 to both sides. Now let's continue. X squared plus 8x plus 16, we can factor that. What are factors of positive 16 that add up to negative 8? The answer is positive 4 and positive 4. So you have x plus 4 raised to the second power. And now we can combine our two like terms on the right-hand side. And 9 plus 16 is equal to 25. And the positive 4 and positive 25 do match the solutions that we just found. So now let's finish the problem and find the values of x. So in order to solve this equation, we have this quantity raised to the second power, or being squared. So in order to undo the square, we have to take the square root of both sides. And when we square root both sides, that square root has a plus or minus in front of it. So we have that x plus 4 is equal to plus or minus the square root of 25 is 5. And now let's subtract 4 to both sides. And when we do that, we'll end up having x is equal to negative 4 plus or minus 5. So x could be negative 4 plus 5 is 1, or x would equal negative 4 minus 5, which is negative 9. So we have two values for our x. And here's the solution fully worked out, and it does match the solution that we found. So our x values are positive 1 or negative 9. Now let's look at the second exercise that we had solved or completed the square for. We had x squared minus 18x, and we figured out that negative 18 divided by 2 was negative 9, and then squared was positive 81. So what are factors of 81 that add up to negative 18? And that's x minus 9 times x minus 9, or x minus 9 quantity raised to the second power. Now if we add up the two constants on the right side of our equation, we will end up having 100. And here we can see that line 1 does match the solution that we found. And now let's finish solving the equation. We have to get rid of this square. So in order to do that, we're going to square root both sides. And remember, because we're solving with the square root, we have to consider both the positive and negative result of the square root of 100. And when we square root both sides, we will then be left with x minus 9 on the left, and then that's equal to plus or minus the square root of 100 is 10. And now if we add 9 to both sides, we will end up getting that x is equal to 9 plus or minus 10. So our x value could be 19, or our x value could be negative 1. And here's the solution to the full exercise shown, and it does match the work that we performed when solving it. Now let's discuss how to complete the square when our coefficient a is not equal to 1. To this point, the quadratic equations that we have solved have had a 1 as the coefficient for a. Now to use completing the square technique for another type of quadratic equation, ax squared plus bx plus c equals 0, where a is not equal to 0 and it's not equal to 1, we're going to simply divide all the terms by a. And we can do that because we can perform any operation to both sides of the equation. So if we divide both sides of the equation by a, we get the 0 over a on this side, which is 0. And then we have to split this long fraction into three separate ones. Ax squared divided by a plus bx divided by a plus c divided by a. And when we do that, we can simplify our first term to get x squared. And then we have plus b divided by a times x plus c divided by a is equal to 0. By dividing both sides of our equation by a, the result is an equation that looks a little bit familiar. If we use substitution and let 2k be equal to b over a and c be equal to negative c over a, the result is an equation that we have solved dozens of times and with the previous exercises. We had x squared plus b over a in parentheses times x plus c over a equals 0. That we found. If we subtract c over a to both sides, we end up getting x squared plus b over a times x is equal to negative c over a. Well, if 2k is equal to b over a, I can take 2k and substitute it in for b over a to now have x squared plus 2kx, and then we have c is equal to negative c over a, so we can take c and substitute it in this place. So x squared plus 2 times capital K times x is equal to capital C. And now we have something similar to our b value where we take half of our b term and square it. Well, half of 2k is going to be k, and k squared is k squared. So we're going to add k squared to both sides of the equation. And then if we factor x squared plus 2kx plus k squared, it ends up being this binomial x plus k quantity squared. And on the right-hand side, it'll be c plus the k squared that we added to the left side, we have to add to the right side. Okay, now let's try an example where we are solving an equation by completing the square when our a value is not equal to 1. We have 3x squared plus 12x minus 66 is equal to 0. Notice 3, 12, and negative 66 are all factors of 3, or multiples of 3, excuse me. So we can begin by dividing both sides of the equation by 3. And when we do that, we will get x squared plus 4x minus 22 is equal to 0. Next, we need to add 22 to both sides of the equation. So we'll end up having x squared plus 4x. After we add 22, this one will go away. And then it'll be equal to 0 plus 22, which is 22. The next step is to fill in the blank space on the left side. So we have x squared plus 4x plus some number is equal to 22 plus that number. So now we look at our b term, 4, divide it by 2, that's 2, and square it, that's going to be 4. So we're going to add 4 to both sides of our equation. And that's how we get this step shown right here. And now that we have a perfect square trinomial on the left, the factors of 4 that add up to positive 4 are x plus 2 times x plus 2, or x plus 2 quantity squared. And when we add up 22 and 4, we get 26. And now we can actually solve it. We could square root both sides, and when we do that, we would get x plus 2 is equal to plus or minus the square root of 26. And then we would subtract 2 from both sides. So x would be equal to negative 2 plus or minus the square root of 26.